My name is Amanda, and today on ITGS Bootcamp, I will be explaining a bit about bits. Now that we have covered hardware and how all the pieces of a computer work together, we can move on to the basic functions of one. Essentially, computers receive, process, produce, and store information through digital units. Just as we use measurements to measure speed, time, and weight throughout our everyday lives, computers also measure information through specific measurements. These are called bits and bytes. These digital units are used to measure space and memory, processor speeds and frequencies, computing speeds, and data transfer rates. Now let's talk about bits. Bits are the smallest unit of information, and are also referred to as binary digits. The binary system was adopted because of the fact that electricity within a computer circuit can only travel in two directions, hence the term binary. The base 2 system works with only two values, 0 and 1, which will determine whether switches within an electric circuit will be turned on or off.
Alright, so I'm going to explain to you guys how to convert regular numbers into binary coding. And since binary works with the power of 2, binary, we're going to be working with the different powers of 2 to convert the number 17. I'm just going to write it down on this table thing. And we know that 2 to the power of 4 is 16, and any number greater than that would be greater than 17, so we're not going to need it. So we're going to use 5 different spaces on this table. That means our final digit will have, our final number is going to have 5 digits. Well, let's get started. 2 over 4 fits once into 17. Which leaves us with 1, 17 minus 16. 2 over 3 fits 0 times into 17. 2 to the power of 2 fits 0 times. 2 to the power of 1 fits 0 times, and 2 to the power of 0 fits once. Therefore, 17 in binary notation is 10001. And there you go.
Now a byte is equal to 8 bits and provides different combinations of zeros and ones to represent 256 individual characters, including numbers, letters of the alphabet, punctuation marks, and other characters. These combinations of zeros and ones used to represent data are defined by patterns called coding schemes. In the early days of computer programming, coders developed their own set of codes and coding languages. This generated a major issue due to incompatibility across different platforms. The initial solution was ASCII. The ASCII coding scheme stands for American Standard Code for Information Interchange. In this case, 8 bits represented a single letter or punctuation mark. Due to the growth of programs being developed in multiple languages, ASCII proved to be insufficient, thus the creation of Unicode, where 65,000 unique codes are supported. Coding schemes make it possible for humans to interact with digital computers that only recognize bits. Every character you type on a keyboard is converted into a corresponding byte. Therefore, program instructions are represented in binary notation through the use of codes. For you to have a better idea on how big this digital information is, here are a few equivalents. A mere 5 megabytes are equal to the complete works of William Shakespeare. A little over 1 gigabyte is equal to the DNA of a human body cell. A terabyte is equal to a set of 1 million novels. The next unit up is a petabyte. This is equal to approximately 42,000 Blu-ray discs. 1 exabyte is equal to the number of small receptor neurons in a dog's nose. And about 20% of Manhattan, New York is equal to 1 zettabyte. Yottabytes.
And no, that does not mean the size of Yoda's bite mark on an intergalactic cookie.
1 yottabyte is equal to the amount of snowflakes that fall on the Earth each year. So today you learned all about the way computers function and process information. For extra resources, we provided you with the link below to the ITGS Bootcamp website. Join us next time when Victor explains everything you need to know about input and output devices. Thanks for watching.